Hi everyone. This is Mohan Raj, Assistant Professor, Department of Mechanical Engineering. Here I am going to discuss about the subject kinematic of machinery, and the other word we can say it as kinematics of mechanics. So before enter into the subject, we have to know something about what is machine. We can say the machine actually which receives energy and transform it into some useful work. So then it will be called as machine. For any kind of useful work obtained from any device, we can say it as machine. So then what is kinematics? So kinematics normally deals the motion of the parts without considering the force, whereas kinetics deals with the action of forces on the bodies. In kinematics, we can say it as without considering the force, the motion will be there. Whereas kinetics, the motion will be there in the machine, but we have to note the forces values. So then it is called as kinetics. And dynamics is the combination of both, combination of kinematics and a combination of kinetics. So this is the kinematic link. So what is meant by link? So the link normally defined as the part of a machine. So we can say it as element or link or any part. So it is defined as a part of a machine which has motion relative to some other part. A link need not to be single unit, but it may consist of several parts which are manufactured as separate units. So here some practical example I have brought here. So this is the reciprocating steam engine. So here we can consider it as four different links. So the link 1, we can notice the piston. The piston rod is mounted on the piston and the crosshead over there. It constitutes a first link. Then the link 2, we can say it as the connecting rod, because why I am telling the piston rod crosshead constitute a first link, because if the piston is moving right side or left side, the piston rod is also moving on the same path. In similarly, the crosshead also moving in the same path. If it is linear, so the crosshead will be linear. If the piston is revolving or rotating, the crosshead will be rotating. But there are some constraints over there. So therefore, the piston and the piston rod will not be in circular motion. It will be only moving to and fro motion. So from that motion, we can translate the same motion into the crosshead. So by observing this motion, the crosshead is also moving to and fro motion. So we can say it as first link. The second link will be the connecting rod with big end and small end bearing constitute a second link, because the connecting rod is moving in oscillating direction. So whereas the piston rod and the crosshead is moving on to and fro motion, whereas the connecting rod is moving on oscillating motion. So it is a different kind of motion. So we can say it is link 2. So and link 3 is the crank, the crankshaft and flywheel constitute a third link. Why I am telling this as separate link? The crank, if the crank is rotating, the crankshaft is also rotating. So the crankshaft is rotating, the flywheel is also will be rotating. So only rotating directions. So we can say it as separate link. So in that reciprocating steam engine, we can say it as different link. And fourth one is rigid link. So here there are some parts are not moving, so we can say it as separate link. Example, we can say it as cylinder is not moving anywhere, so cylinder, and engine frame is there, so engine frame is also not moving, and main bearings from the form here fourth link. So cylinder, engine frame and main bearings form a fourth link. And another types of there are different types of link. So the first one is rigid link. So the rigid link is a link which does not undergo any deformation while transmitting the motion. So it should not undergo any deformation. What is meant by deformation? You can easily understand the deformation by studying strength of materials. So the deformation is nothing but, so there are some elongation. So there are some shape in changes in shape or changes in dimensions. If it is linear dimension or lateral dimension, so we can say it as deformation. If any part is not getting any deformation, we can say it as rigid link. And for example, we can say it as in the previous slide, we can say it as the connecting rod is the rigid link, and crank pin is a rigid link, and bed spindle of the lathe do not have any appreciable deflection, and as such as they can be termed as rigid links. Then another one is flexible link. Flexible link is partly deformed in a manner not to affect the transmission of motion. So it can be deformed partly, and but it should not affect the transmission of motion. We can say it is flexible link. And another one is fluid link. When motion is transmitted by means of a fluid, it is known as fluid link. For example, hydraulic press, hydraulic jack, hydraulic cranes. So it acts as a link, that is a fluid link. And kinematic pair. So what is meant by pair? The two elements are joined, and it should permit the relative motion between the two links. So that means when two links or elements are connected in such a way that their relative motion completely or successfully constrained motion. So what is meant by completely and successfully completely, I will be telling later. So this is the kinematic pair. The two elements are joined together, that should permit the relative motion between the two elements, so that will be known as kinematic pair. For example, crank is a separate link and a connecting rod is also separate link. If the crank and the connecting rod are joined together, it will be known as one kinematic pair. Similarly, connecting rod and piston and engine cylinder, because piston is a separate link, engine cylinder is a separate link. So if the two links are joined together, we can say it is kinematic pair. So this is the types of kinematic pair. So here we can notice the different types of lower pair and higher pair. So what is meant by lower pair? If a pair in motion has a surface contact between the two elements, it is called a lower pair. It will be seen the sliding pairs. So this is the sliding pairs. So we can see it as we can see the lower pair. If the pair in motion has a surface contact between the two elements, it is called a lower pair. Practical, we can say some examples: nut and bolt, bolt and socket joints, shaft rotating in bearings, piston reciprocating in a cylinder. So these are all the sliding and surface contact. So we can say it as lower pair. So what is meant by higher pair? If a pair in motion has a line or point contact between the two elements, between the two links, it is called a higher pair. So as I have already told that the elements, links, part, component, so all are same. So don't get any confusions on that. And we can say some examples: belt, rope and chain drives and roller bearings. So which there is a line contact. Gears, cam and follower, a pair of friction wheels and ball bearings, etc. So in which there is a point contact. So if it is point contact, so that will be called as higher pair. And the types of constrained motion. So what is meant by constrained motion? If any motion is arrested by some another element, we can say it as constraint. So I hope the meaning of constraint everyone knows. So this is the completely constrained motion. So there are three types of motions: completely constrained motion, incompletely constrained motion, and successfully constrained motion. Completely constrained motion, when the motion between a pair is limited to a definite direction, so then the motion is said to be completely constrained motion. Example, so in this diagram we can notice a square bar moving in a square hole. So there will be only one possible motion, so that is to and fro motion. So there will not be any rotating motion. So only one motion is possible, so this is a constrained motion. And another one is incompletely constrained motion. So when the motion between a pair can take place in more than one direction. If it is more than one direction, we can say it as incompletely constrained motion. A circular shaft moving in a circular hole, so as shown in figure here, have two types of motions. One is rotary motion and reciprocating motion. Reciprocating motion means sliding motion. So this motion is incompletely constrained and both motions are independent of each other. So this is called incompletely constrained motion. And final motion is successfully constrained motion. What is meant by successfully constrained motion? When the motion between the elements is not completed by itself but by some other means, then the rotation is said to be successfully constrained motion. So if it is not if it is incompletely constrained motion, we have to convert into the completely constrained motion by means of any external force. So in this diagram the load is the external force. So this is the footstep bearing. If the load is not applied here, what will happen? Definitely the shaft will be moving to and fro motion. So that will be incomplete motion. So now we have to convert into the completely constrained motion by means of any external load. So this is the successfully constrained motion. So example for successfully constrained motion, the motion of piston inside this engine cylinder is not completely by itself but due to the rotation of crank. So similarly the engine valves are not having their own motion but they are operated by rocker arms. So likewise, so the footstep shaft and footstep bearing is also example for successfully constrained motion. So we are having some problems to identify whether is different kind of chains. So before that we have to know what is meant by kinematic chain. So kinematic chain is defined as combination of kinematic pairs, so joined in such a way that the relative motion between the links or elements is completely or successfully constrained. A chain may be locked, constrained and unconstrained. So to determine the some assemblage of links form the kinematic chain or not. If it is kinematic chain, so how will we identify? If it is not kinematic chain, how will we identify? So there are some equations to identify. It will be locked chain, it will be unlocked chain, it will be unconstrained kinematic chain. So such a way, so we have to identify so what kind of kinematic chain in the assemblage, right? So tomorrow we have class. In the class we are going to solve some problems to identify whether it is kinematic chain or not. So thank you so much.